Thank you. I'm not sure I've ever had lights flash before when I've showed up on anywhere. This is probably the biggest room I've ever presented in. It's most certainly the biggest screen. Earlier I was worried that some of my fonts might be too small, or I'd have to adjust Visual Studio so you could see the code, but all those fears are gone. I think you could, read anything up on there without any problem. So my name is Brad Sullivan, and I'm coming to you from Redmond, where I am a program manager on the Visual Studio team. More specifically, I work on the Diagnostics Tools team within Visual Studio. And then if you want to get even more specific than that, I primarily work on the Visual Studio debugger. And I've been doing that I've been on that debugger team for about 5 years now. So I'm really passionate about debugging tools and diagnostic tools. And some of you might have heard me speak yesterday, and today I'm going to talk to you a bit about the diagnostic tools we have in Visual Studio that can be used to diagnose your ASP.NET applications, particularly in production. So what are we going to talk about more specifically? First, I'm going to talk a little bit about what the challenges are that you see in production that you don't necessarily see during the development part of the cycle. And then I'm going to talk to you about 4 different tools that we have within Visual Studio that you can use for diagnosing those issues. The first of those is the remote debugger. The second one is IntelliTrace. We also have the dump debugger and the performance profiler. Finally, I'm going to talk about sources and symbols and how those play an important role in building that end-to-end scenario where you're diagnosing things that are production apps. Okay, so what are the challenges in production? Well, first off, why would you ever try to diagnose something that's in production? Well, the main reason for that is that your customers, your users, whoever they are, they're running into an issue that you cannot reproduce in your development environment or your test environment. So really, you can either just stare at your code all day and try to guess what's going wrong, or you can try to use some diagnostic tools on the production environment where that issue is happening to help you out. A challenge is that you usually can't run Visual Studio on the production machine itself, depending on what your relationship is with your operations team. The level of access that you get as a developer and the amount of impact you're allowed to have on those machines can be fairly limited. So what we want is tools that make the right trade-offs for minimizing impact to the server in terms of the server's performance, its availability, as well as its security. So now, given those limitations, the first tool that I'm going to talk about is the remote debugger, which in this case I call the big hammer, because while it's the first one I'm going to talk about now, it might actually be the last one that you end up going to. Why is it the big hammer? Well, everybody wants to use the debugger, and the remote debugger is just that. It's 100% as powerful as just debugging locally. It's what the developer is used to in terms of being able to attach their process, step through, inspect the state of their app, do everything that they need to do to try to solve the issue. So what are the advantages of the Visual Studio Remote Debugger? Why is it a fairly decent production tool? Well, one, as I mentioned, it's the most powerful tool in many senses, and it's often the fastest way to resolve your issue. It is actually Xcopy deployable. Not everybody realizes that, so you don't need to run an install on your production machine to use the remote debugger. That doesn't mean that it has zero impact, but you at least don't have to convince your ops team to let you run that installer. The way to Xcopy deploy it is actually just going to its install directory under program files. And from that directory, you can grab just that whole directory and just copy it and move it to any server you want. And then you can just execute msvsmon, which is the executable for the remote debugger, and it will start right up. It does also have configurable authentication, so it is reasonably secure. So you can adjust who is able to connect to that. Disadvantage is your service becomes completely unresponsive once you're stopped in the debugger. Once you've hit a breakpoint or an exception, the debugger is going to stop. It's going to suspend all the threads are going to be suspended, and anybody else who's trying to hit that server and use that process is just out of luck. So you have to make the right trade-offs there for what's right for your customers. Is a little bit of downtime the right trade-off for being able to fix that problem faster? And the other disadvantage is it does require some firewall configuration. So that's where it does have some impact, even though it is Xcopy deployable. So the remote debugger is actually reasonably different in Visual Studio 2012 than earlier versions, even though the UI looks exactly the same. Underneath, it's been completely rewritten. So on your client side, you just have Visual Studio, and now that talks over TCP to MSVSmon on the remote side. And what that means is that previously we had sort of a two-way or two one-way communications between the Visual Studio and MSVSmon, which meant that you had to open up the firewall on both sides equally. But that's not true anymore. You now only need to open up the firewall on that server side. And then MSVSmon just talks to your app just like the debugger would on the client side. So what improvements did we make in the remote debugger in Visual Studio 2012? Well, as I mentioned, we do have the single firewall configuration. It's on the remote debugger side. It's also a single-click configuration. So if you launch the remote debugger and your firewall is not configured, it will detect that and just give you a single button that you can click, which will elevate and open up the right ports for you. It can connect across different domains now. So if you're on a production machine, or if you have a production environment where all of your development happens on domain A, and even like your staging and your production code is running on domain B. In previous versions of Visual Studio, the remote debugger could not talk across that boundary, but that's no longer the case. Now it can. And in fact, it can talk from a domain to a non-domain machine if you want it to. Symbols now load from the Visual Studio side. This was always the case when you were debugging native code, but we're talking about ASP.NET in this room today. And the way it worked before was you had to have your binaries in a path relative to where the symbol files you had to have in a path relative to where the binaries were. And of course, the binaries are on the remote machine in that case. So what did that mean? You had to copy the files over the symbol files over to your production machine, which has a couple of problems. One, that's creating a greater impact on that machine, and two, it's potentially unsecure because now your symbols have a little bit more information in them about your app as opposed to just the compiled binaries, and so you're providing an additional layer of access to that information by moving it across the boundary. It's a lot faster now than it was. We did in our big rewrite of the remote debugger. Came out a lot faster, so you don't have to worry about stepping being incredibly slow or anything like that while you're remote debugging. And additionally, there's no reason that you would need to choose between x86 and x64. Previously, what you would have to do is side-by-side install two versions of the remote debugger and then connect to the one that had the matching bitness. That's all changed. So now, if you have a machine with an x64 operating system, which you most certainly do if you're running servers, then all you need to do is install the x64 version, and it will automatically manage a connection with the x86. It takes the x86 version with it and automatically manages that connection so that you don't need to do any manual configuration there. It's sort of an it just works approach. Okay. Now, before I move on to IntelliTrace, I'm just going to pull up the remote debugger real quick. So the UI you can see is really the same as it has been in previous releases. You can switch. You can change the authentication to give specific people privileges. There were a lot of cases in the past where people would just sort of flip to no authentication mode in the remote debugger because they just couldn't get it to work otherwise. Now with our new system, there's almost no reason to do that. The only because it just always works. The only real reason somebody might try that is if they have an account with no password. Then you have to use no authentication. But otherwise, the Windows authentication works great. And although these are on the same machine, so I'm not presenting from, well, I am actually presenting from two machines, but not ones that can talk to each other right now. The way to connect to a remote machine has changed. There's the string that you enter as the qualifier here and attach to process is slightly different. You can just put machine name or machine name : port. For me to connect to the remote debugger on the same machine, I have to put the port. So you can see that I have now connected. So there's no reason that anymore that you need to put in @ or anything like that to get connected. If the name isn't resolving via DNS, then you can also just put in the IP address of the remote machine, and that works fine. If you do happen to have multiple remote debuggers running at the same time, because they do run side by side, then port 4016 is the default port, but you can have multiple instances running on multiple ports, and then choose your connection to whichever one you want. And in that case, entering the port in the qualifier would be mandatory to not connect just to the default one. Okay. So the next tool I want to talk about is one that we talk about quite a bit when we're talking about production scenarios, and that is IntelliTrace. So what is IntelliTrace? Well, it's sort of our back-in-time debugger. And what we mean by that is it gives you the same sort of interface as the regular debugger, but it gives you the opportunity to step backwards through your app and see the state of the app at different times. It's a configurable logging mechanism that traces the state of your app over time, and you can run it either locally or from a command line. And so if you're running it from a command line, that's your production scenario where you don't have Visual Studio on the box. So how do I run IntelliTrace in production? Well, the first thing you do is you download the IntelliTrace collector, which is a collection agent that's free to download, and you can just run it anywhere you want. Then you run that on your production machine. You pick a collection plan. You target the application, and then you let it run. So you can either keep it running indefinitely and just keep track of the logs, or you can have a more targeted run where you know that the issue is going to reproduce in the near future, and so that you're turning it on, the logging's going, the issue is reproduced, then you collect that log and you take it back to your development machine, and you analyze it in Visual Studio to find the bug. So I'm actually going to demo this real quick. So I'm going to shift over to this machine here. So there's a little... Let me... There we go, that's much better. Okay, so let's see. Let's say I am on this machine here, and I'm going to go to this Fabricam Fiber website. And what this has is it has a list of tickets that customers have filed for me to take a look at. So I'm going to click through these tickets, and that's fine. And then, when I click on this one, I get an error. So there was an error while retrieving data from the server. So I don't know what data that is, but I'm going to use IntelliTrace to try to find out. So the first thing, as I mentioned, that you would do is you would download IntelliTrace. So what does downloading IntelliTrace look like? Well, all it is a cab file, or sorry. It is a cab file, but what you receive before the cab file is you actually download an installer. And what does the installer do? All it does is pop a, it just pops a EULA and then allows you to get that cab file that I mentioned. So the installer is completely a mechanism to get you to agree to the license agreement. Once you've agreed to the license agreement, then you can take the cab that pops out of there and move that anywhere you want. So if you want to run this on a production machine, you just take that cab and just copy it over, and you don't have to run the installer every time. Okay, so I've now so I already have IntelliTrace on this machine. So what I'm going to do is I'm going to start PowerShell, and PowerShell is the interface for IntelliTrace in production. Let's see if I can avoid making typos. I actually think I have this in here so I can not make a typo on stage. How's that? Okay. So the first thing I do is I just import that module. So now I have IntelliTrace loaded, and let's see what it can do. So what commands are available to me? So I'll just take a look there. Okay. So that listed out my IntelliTrace commandlets. I see what looks like a start IntelliTrace, a stop IntelliTrace, and then some status, and looks like a checkpointing function as well. So now what I'm going to do is I'm just going to go ahead and I'm going to start the collection. Okay, so I'm running the start collection, and then I'm giving it my app pool that I'm going to run it on, which is this fabricamfiber.extranet.web, and then I'm giving it a collection plan. So what is this collection plan? I'll dive a little bit more into that later, but I'm choosing the trace collection plan, and that's stored as an XML file. And finally, I'm giving it a location, and that's where it's going to store the eventual IntelliTrace log that's produced from this process. Okay, so it wants me to confirm that I indeed want to start IntelliTrace, so I'm going to do that. Okay, so IntelliTrace is now running against that app pool. So now what I need to do is I need to reproduce the issue. I'll load up this web page here. I don't think it got my button click. Oh. There it goes. All right. So now I'm going to click through these guys. And there's my error again. All right. So now I am done reproducing that issue. Let me quickly just quickly check the status of my IntelliTrace collection. All right, that seems to be running okay, and it seems to be have an output file, so that's good. So since everything looks fine and I've reproduced my issue, I'm just going to go ahead and stop the collection. So I stop the collection just by calling stop IntelliTrace collection, and again, my app. Again, just like starting, it wants you to confirm. So yes, I want you to stop collecting. Okay, great. I am done. So now what do I do? Well, I stored this guy in this log file collection file here. And as you can see, it was written at 2:10 a.m., which is what time it is in Seattle right now. So I'm going to go ahead and open this IntelliTrace log file, and it'll just automatically open with Visual Studio. All right, so now this gives me a view of what exceptions were happening, which is sort of the top level of what's interesting. So I think this null reference exception is probably the interesting one. These exceptions tend to come in groups, as there can be a lot of throwing, catching, rethrowing. That's all going to get logged. So I select that. I'm going to select the first one so I can get the earliest view of when that happened. And then it gives me a call stack, which I find interesting there. And I can start debugging on that call stack. And now you can see that when I start debugging, it actually takes me into the familiar debugging view, where I have my locals window. What's different is I do have this this gutter here. Let me bring up the IntelliTrace window as well, the IntelliTrace pane, so I can see my different items of what's happened. I can go back to earlier events and back forward again. So I think from this information, I can actually see what's wrong with my app here. This service ticket assigned to is null, but right here I'm referencing service ticket assigned to full name. So that's obviously not going to work. So that's where my bug sits, and now I can go back to my development machine and go ahead and fix that bug. Okay. So I was talking about the collection plans earlier, where I just sort of chose one that was called trace. Turns out that there's two default levels. They're essentially the same between when you're doing the F5 IntelliTrace experience and when you're doing the production experience. The higher level, sometimes referred to as calls, where it's going to log the function calls, right? So that's going to be pretty heavyweight. And then the lighter version is where it's just logging specific events. So it could be like data binding events, or it's certainly exceptions. It could be certain UI inputs and everything, where it's just going to log a lighter amount. So those are the two options. Can you customize it? Yes, you can. It does involve editing the XML. It's not super intuitive, but you can accomplish a few things doing that if you want. You can turn individual events on and off. You can include or exclude modules. That can be somewhat interesting if you're getting a lot of noise from, let's say, a third-party module. You can exclude it from the list. By default, IntelliTrace is already excluding a lot of things in the CLR itself, so that you're not seeing that washing out the information that you're trying to look at. And finally, you can change the max log size. So if you really wanted to look at that, you can just see the XML here. It's a collection plan. Here's like you have module include lists. You have your max log file size. 4,000 is kind of a deceiving number. I think each of those 4,000 represents 64K. I think that it's number of 64K bytes. So as you can see, the XML file is a little bit intimidating. So it's a bit easier to stick to the defaults for now. Okay. So what's the impact on server performance? Unfortunately, the answer to that question is, well, it depends. It depends on the number of events collected. If your app happens to, throw a lot of exceptions for execution control or for whatever reason, it's going to slow down a lot more than some of the others. You can also, calls is going to be fairly heavyweight. If you have a highly recursive application, that can make the performance impact a little bit higher. The number of modules included in the application also has an impact because they do have to, at least on startup, JIT all of those modules. And finally, the I/O performance, since you are writing this to disk as a log, your I/O can have can make a difference. So really, what it comes down to is you kind of have to experiment and see what works for you in your staging environment. Of course, if you have a more immediate problem, then and you're having a bunch of server downtime because of it, then you might be better off just making that trade-off sooner rather than later, and just get it over with and run IntelliTrace. Another recent development in IntelliTrace is System Center integration. So with System Center 2012 SP1 Operations Manager, you get a couple IntelliTrace features in there. You also need to have Visual Studio 2012 with Update 1 to get the Visual Studio side of that. And there's really two things. So the first is that the application performance monitoring that's been a part of Operations Manager is now available in an IntelliTrace format. So you can take that data that APM, they call it, has collected and import it into Visual Studio as an IntelliTrace log, even though it was not collected by IntelliTrace. Alternatively, there is an IntelliTrace profiling management pack that allows you to use the Operations Manager console to configure IntelliTrace and collect logs on your applications. So that can be really handy. APM and IntelliTrace don't work at the same time, so you do have to choose one or the other. And that's because they are both I-core profilers, meaning they're both CLR profilers, and the CLR only allows one profiler at a time. Okay, so I talked about IntelliTrace, which gave you sort of a longer historical view of what your app has been doing. But one alternative to that is using dump files to diagnose your issues that are happening in production. So a dump file is just a snapshot of the application at a single point in time. There are two major types of dumps. One is with heap, which allows full inspection of the state of the process at that one point in time. And the other is without heap, which is really all you're going to get without heap is you're going to get the call stacks for all of the threads. And you should be able to get most of the parameters for those call stacks as well. Both types of dump files can be opened directly in VS and debugged just like any regular application. But of course, since it's a single snapshot, a single point in time, there's no execution control or anything like that. You can't set a breakpoint in a dump. You can't step a dump. It just wouldn't make sense. How do I create dump files in production? What is the best way to do that? There's actually a lot of tools out there that create dumps, and they all have their pros and cons. Visual Studio, for example, can create dumps. We did actually recently ship a feature, again in update 1, where if you're remote debugging, you can create a dump and save it directly to your development machine as opposed to on the production machine. So we added that pipeline. But I think that for the general scenarios of production diagnostics, proc dump actually does a better job. So there's a few reasons for this. One, proc dump is a command line tool, which makes it very easy to have somebody on the server configure and everything. It is Xcopy deployable. It just comes right as a zip file that you can unzip. And probably most importantly, it provides specific triggers for dump collection. So if there are certain things that are going wrong in your application that you know about, you can set up proc dump so that it will collect dumps when those things occur. Examples of this, you can set it for CPU usage. You can say, hey, if my application starts spiking over 50% CPU, I want to see where it's spinning, and you can make sure it grabs a dump at that point. In fact, you can configure it at once to say, hey, when it starts spinning like that, collect 3 dumps, with X amount of time between them, which might also be helpful. You can have it snap when memory usage gets over a certain point, and when exceptions occur, even first chance exceptions, and you can apply filters on that. So you can say this type of exception or an exception that matches this pattern, and it will automatically collect those dumps. Another advantage of proc dump is it has a very low impact on system performance. It does a secret trick in Windows where it does not need to hold the process for the entire length of time when it is writing the dump. Because a lot of these dumps, they can end up being a few hundred megabytes. And so if they're a few hundred megabytes and it takes 15, 20 seconds to write that, you might not necessarily want your application to be hung for that period of time, because that's what would happen otherwise. So it can actually let your application keep running while it is writing the dump. And proc dump is available through Microsoft sysinternals, and I have a URL there. I'm just going to show a really quick demo of what proc dump can do. So let's see. All right, so I'm just going to go. Oh, you still have that up on the screen. Okay. Sorry, that's not on my screen, so, oh, interesting. I can drag it off, but then I can't see it. Let me see if I can stop this slideshow for a second. There we go. Okay. So, so what I'm going to do is I'm going to quickly start an application. This is a server app. Oh, I think it might be running. Yeah, it's already running. Let's try that again. Okay, there we go. And now what I'm going to do is I'm going to tell, I have this command for proc dump here. And what I'm going to tell it to do. So it's kind of a messy looking command line, but here if you can see MA is essentially telling it that I want the dump with heap. And then I have an E1. E1 is telling it to stop on first chance exceptions. And then I have -F and then a string. My string is HTTP in this case. And what is that? That is that's a F is for filter, and so that is filtering the exceptions to things that have the string HTTP in them. Then I give it the name of my app, which is just my server exe that I'm running right here, and a location to write it. So I'm going to go ahead and start proc dump. So it has started, and it is now monitoring my web server. In the meantime, I'm going to hit my web server in my browser. Oh, there it goes. So my page loaded, and I hit an exception that had an HTTP in it. And so proc dump has written out this dump file. Now, Visual Studio, all you need to do if you have Visual Studio installed is just click on the dump file. It will open. You can, from here, you can set your symbol paths if you want to. And then you have a choice. You can debug with mixed, or you can debug with native only. So there's not currently an option for debugging with managed only, even though that's what you might want for ASP.NET. But if I debug this guy with mixed, I can get to that exception information, where essentially I'm missing a file. File name is not a valid Win32 name. So that's a way I can quickly just get an artifact from a production machine that's going to help me, find my issue and diagnose it in Visual Studio. So let's keep going here. Okay. Okay. Finally, what the next tool that I want to talk about is the performance profiler. So the performance profiler essentially has 5 modes. So it has CPU sampling, and what CPU sampling does is it shows what parts of the application are executing the most frequently. It has an instrumentation mode, and what instrumentation mode does is instead of taking that statistical approach that sampling does, it records how long functions take to execute and how many times they are executed. That does mean that you have to instrument your binaries before doing that type of profiling. There's .NET memory allocation, so it tracks what objects are getting allocated over time. There's resource contention, which is for multi-threaded applications. It tracks when threads are contending for the same resource, causing slowdowns in your application. And finally, but certainly not the least of which, is tier interaction profiling. What tier interaction profiling does is it records all the database queries that go through ADO.NET and gets timing information for that. So it sort of does since essentially no ASP.NET applications out there are single tier applications. It allows you to see the performance issues that are caused by those cross tier parts of your app. So the profiler can be run locally from your IDE, but it can also be run in production from the command line. So there's a standalone installer that comes included when you install Visual Studio. So if you just go to that directory, you can grab the setup and move that to your production machine so that you can solve those performance issues there. And tier interaction profiling can actually be used simultaneously with one of the other profiling methods. For example, instrumentation. And in fact, I'm just going to go ahead and give you a demonstration of what that looks like right now. So here I have my Tailspin application, and okay, and I've got this command prompt. This is a Visual Studio command prompt, so all my Visual Studio commands are currently in the correct path. And now, first thing I'm going to do is first I'm going to make sure that I shut down my web server. So I'm going to do that. Now it's gone. And then I'm going to set some environment variables. So what these do is they make sure that the CLR gets loaded in the right way so that profiling of a managed app can be enabled. So I'm doing it twice. Once for trace profiling, and that's going to be the instrumentation profiling, and once for the interaction profiling, which is the tier interaction profiling. The next thing I'm going to do is, since I'm going to use instrumented profiling in this case, is I'm going to run a couple commands that are going to instrument my binaries. Oh, okay, so that one's already instrumented. That should be fine. This one might already be instrumented as well, but I'm going to run the command just in case. Okay, so they're both instrumented, so that's good. And now I'm going to turn on the profiling itself. So the command for doing that is using the vsperf command start, and I'm going to choose live profile as my file name. So that is going to be the actual live demonstration. And okay, so now that should be turned on. Good. So here I am just launching my web server again, since it was shut down. Okay, web server is now set up. Let's go back to that website. Okay, so I was thinking about it, but that took probably a bit longer than I wanted it to. So I think that there might actually be something that's making it go slowly on startup. So let's go and see if we can find what that is. So the first thing I'm going to do is shut down my web server, and then I'm going to stop profiling so that I can actually get that trace that I've just collected. Okay. So here's the directory where I saved that. Oh, there it is. Popped up. Live profile. All right, that's the one I just saved. 2:36 a.m. Seattle time. Great. Okay, so now I'm just going to open that up. The file is not currently associated with Visual Studio. Now it is. And it starts analyzing it. And let's move this error list. All right. Now let's see what we've got here. So when I open this VSP file, which is the profiler file, I can see what my hop path is. So this is essentially the path that's taking the most time. Sometimes, it doesn't, what's going wrong doesn't quite pop out there. So I'm going to keep looking. So then we have functions with the most individual work. And so there's one function here that has a ton of individual work. It has 58.37%. So what is that? It's a system data link data context. Okay. So it looks like it's a query. So maybe indeed it is something that is between my two tiers that is causing the problem. So I'm going to go up here and switch from the summary view to the tier interactions view. And I'm going to go ahead and expand that. Okay, so what's popping out to me here? Okay, I've got this get customer query right here, and that's taking by far the most time. So the amount of time it's taking individually isn't that bad. Maybe I have a ton of customers and that just takes a while to load. But it is kind of suspicious that I'm running it twice. Okay, so what am I going to do? Let's see if I go back to the summary view. And now I'm going to click on this guy. Okay, so this guy is getting called by select customer, and let's see the functions there. Okay, so that function is getting called twice, and that's select customer. So from here, I can jump to the source code, and essentially, I'm at a point where, I figured out that I'm running this query twice on page startup, and I clearly only need to run it once. And so I could just implement a caching system or something and fix my application that way. Okay. Jumping back to the presentation here. All right, so the next thing I want to talk about is symbol files. So I showed you 4 tools, 2 debugger tools, Profiler, IntelliTrace. They all need symbol files to function properly. Symbol files provide a mapping between the binaries you're analyzing, the binaries you've built, and the source code that produced them. So to fix your problem, you got to get back to the source code, and you need the symbols to tell you how to do that. They also tell you information, among other things, the information necessary for determining what the local variables are for a function, which is also extremely helpful when you're diagnosing any issue. Symbol files must exactly match the build that you're diagnosing. So you can't load symbols from a build you did at 2:30 p.m. With a build with binaries that were built at 2:31 p.m. They won't match, and none of the tools will be able to load the mapping that way. It's easy for your development environment to get out of sync with your production environment, and for those to have 2 different versions of the code. So it's really important to keep these all together, so that you can always get back and find what's going on. In Visual Studio, well, let me talk about source indexing first, actually. So what is source indexing? So source indexing actually is it's when your build embeds a command into your symbol file for each source file that was used to build it. And then diagnostic tools that are reading the symbol file can then execute that command to find the source file. So it's something that's you can do optionally, but it's very powerful in terms of tying it all together. Instead of finding your source and your symbols separately, it turns that into one task of just finding your symbols, and then your symbols know how to find your source. In Visual Studio 2012 Update 1, we did improve the user experience for loading source files in this way. So I don't know how many of you might have seen this security warning dialog that's showing up there. And it says, oh, the symbol file blah indicates that the following command must be executed to obtain the proper source file. And that's the command that source indexing embedded in the PDB. In earlier versions of Visual Studio, before Update 1, you had 2 options. You could run or you could don't run. And that was a time waster, because what would happen is you never have one source file that you're looking for. And so it was going to prompt you over and over and over again for every single source file that you try to load this way. So we've changed this, and that did ship with the update, so that you have a couple new options. So option number 1 is you could just always trust the source server commands. Now, if you always know where you're getting your symbol files from, that might be fine, because if you know how they were built, you might know that, yeah, nobody's embedded some sort of malicious command in there for me to run, and I'm okay with just running that, and that's fine. If you wanted something that's still more convenient, but not quite as open, you can also choose to just trust a whole symbol file, and then we won't prompt you for any of the files that were built for that binary. So you can trust a binary all at once. Okay, so TFS actually does support. It does support using your build definition in TFS to save your symbols and index your sources. When you do this, if you're going to have a build that is deployed to production, that's something you're going to want to keep essentially forever, or as long as you care to ever diagnose it, as opposed to throwing it away. So I can show you really quickly what that looks like. So if I go back to this other machine here, I'm actually going to stop my IntelliTrace. I can go to Team Explorer, Builds. Oops. Don't tell me I lost it. Well, I might have accidentally deleted the build definition here, but if you look at the screenshot, you can see that indexing the sources is just as simple as setting a flag to true. And the reason for that is this thing already knows what you're building. It already knows where your source files are stored, so it knows the command for getting them. So you just turn that on, and then you can just give the build definition a path to publish the symbol server. And once you have that path, you can then just enter that into Visual Studio. In your symbol settings, and Visual Studio will load all the symbols from that path. And so when you're doing all this in production diagnosis, it's just going to work. All right. So that was just about what I wanted to talk about today in terms of production diagnostics. There are a couple additional things that I want you to know. Number one is we have a team blog, the ALM team blog, where we will be constantly adding more information about Visual Studio diagnostic tools, especially tools that help in production scenarios. So that'd be worth checking out and keeping on top of. If you wanted to know about that. The other thing that I wanted to point everybody to is our user voice site. So every time I meet anybody who is a software developer, they always ask me, "Hey, can you add this feature?" And I really love it. I really like getting that direct feedback from the customers. What user voice lets us do, it helps us sum those in an efficient way. So you can go and add your feature requests, and you can go and vote on feature requests that other people has made to push them up the list. And I can tell you for sure, as we're working on future versions, that we take it extremely seriously when items really start bubbling up there. So it is really effective. Okay, with that, that is all I have. If anybody has any questions, I'm certainly open to answering any of them. Although with this very large theater, I'm having a very hard time seeing just about anybody back there. So.